it, Jim. I'm a scientist, not a firefighter. It's another Science in the City day here at the Toronto Fire Academy, where we're doing the science of fire, helped by some of Toronto's best and brightest firefighters, right?
Yep. Exactly.
Yeah, okay. What is fire? Tell me what fire is. What do you need to make fire?
First of all, you need fuel.
Okay.
You need heat.
You heat?
You need some oxygen.
You need oxygen. Put those three things together, Alf, what do you get?
You get a self-sustaining chemical reaction called the fire tetrahedron.
Okay, so the fire tetrahedron, that's got four sides. The triangle is the oxygen, the heat, and the fuel, but those things together make that self-sustaining chemical reaction. That's the fourth element. And this idea of a self-sustaining chemical reaction is really important because fire is a chemical reaction, right? And what's the key chemical?
Oxygen.
Exactly. So in chemical reactions, the rate at which they operate is limited by the availability of the different things in the chemical reaction. And if you have a limited amount of oxygen, that limits the rate at which the fire can burn. Let's imagine we have more oxygen available in the atmosphere. What's going to happen then?
You have a much more intense reaction.
That makes a lot of sense, but the only way to find out for sure is to do some experiments. So let's make some fire, okay? So we're going to put this wood on fire in a regular 21% atmosphere, and we'll let it burn a little bit. And then we're going to go to Bill, and Bill's going to add the liquid oxygen, and we'll see what happens. Now over here is where we add the liquid oxygen. Now this is minus 183 degrees, very cold, but it's nothing but oxygen. So Bill, you're going to add a little bit of liquid oxygen to the fire, and we're going to stay well back. Pour the rest. What did you see?
Well, with the increased oxygen, the fire intensified to the rate of an explosion.
That's right. We accelerated the chemical reaction that is fire by making oxygen available. And now what do we have going?
Now it's just burning at a normal rate, using up to 21% available in the air.
So we just burned a little bit of wood, and it flames really nicely. That's why we use it around campfires and so on. But let's try something a little different. Let's try charcoal briquettes. Now, Captain, do charcoal briquettes burn like wood?
No, they don't. Once we get them lit, then they tend to smolder and burn much slower.
They burn much slower. Okay, and that's good, I guess, if you want to cook over them.
Yes.
Because you don't get a flame.
That's right, but it does take time. You have to wait for them to get hot enough to cook on.
What if you don't want to wait?
Let's add some oxygen.
I'm going to give you a little bit more than I gave you last time. Okay, Bill, let's oxygenate those briquettes. A little dab will do it. Let's see what happens. So what you got happening, Rob?
Very warm.
Get the stakes out.
A real-world application of liquid oxygen. Up in Sudbury, when they're roasting the ores, in some of the smelters, they inject pure oxygen into the smelter to incinerate the ore that much faster. Okay, so we're on our last reaction here. We saw in the first two with the wood and the charcoal, where you add oxygen to the chemical reaction that's fire. You accelerate it, right?
Yep.
Yeah, it just burns that much faster because all of a sudden that chemical reaction can go that much faster. Okay, for this experiment, we're pulling out the steel wool. Now, does steel wool burn?
Yes.
Does it burn very fast?
It will burn kind of slow.
Let's add the oxygen and see what happens to the steel wool. See if the steel will continue to burn. There we go, we got it. Yeah, that's good, that's good. Okay, positions, everybody. Oh!
Alan, you broke your pan.
Okay, so folks, what do we see?
Looks like it's just melted. It's just molten.
Steel wool's gone.
It liquefied instantly, which of course is what it was, when it's burning, it's doing that slowly, but you add the oxygen, and what happens to the chemical reaction rate when you add the oxygen?
It just goes right up and it increases.
As a firefighter, what do you think life would be like if we increased the amount of oxygen in the atmosphere?
We'd be a lot busier.
And oxygen tends to be the limiting factor in the rate of the chemical reaction in fire. So you add oxygen, the chemical reaction is accelerated, and what do you see?
Explosion of fire.
Here we go. Hey!